As I said, what we're doing today is not new. There's nothing in this that's new. The difference is, and you've been dealing with word problems since junior high math, maybe even in elementary math, and the word problems start off as something very, very simple, like, I don't know, Tom and Sally have $14. Tom has $6. Then how many dollars does Sally have? I mean, that's a childlike example. But you might have been taught something like that by an elementary teacher to introduce you to the idea of an equation. That the number of dollars that Sally has is going to be equal to 14 minus the number of dollars that Tom has. Okay, it's all about building equations. The thing that's different now is the word problems have progressively got more complicated, and up until this unit, you didn't know how to solve word problems if they resulted in a quadratic equation. Because before this unit, you didn't know how to solve a quadratic equation. That's the only difference here. So I want to go through with you two examples of word problems where we build an equation that turns out to be quadratic. So the first question says we have a right triangle. Let's just imagine what a right triangle looks like. It's got a hypotenuse and it's got two small sides which are called legs. So I don't know if this has been taught to you or if it's been really drilled into your heads in other math classes, but the two sides that are not a hypotenuse are called legs. There's usually a short leg and a long leg. It says the hypotenuse is 6 more than twice the shortest leg. Well, let's start by defining a variable. We have to define a variable first. We have to define x as being something we want to find. You don't have to use x. You can use any letter you want, but x is famous for being that unknown. X is going to be the length of the short leg. And we're going to build everything else around that idea. So what is the hypotenuse? Well, the hypotenuse, I don't want to write, give me a second to write this down. I don't want to write h equals. I don't want you to think I'm introducing another variable. I'm not. This is the hypotenuse. What does it say about the hypotenuse? Look up here, please. When you translate words to math, there are certain rules. One is that the word is means equals. Okay, if something is 5, then it equals 5. And then we just read the rest of it. 6 more than means we're going to add 6 to something. 6 more than what? 2 times the shortest leg. So that's the hypotenuse. The longer leg, or the long leg, what does it say about the long leg? Well, it doesn't really tell you directly, but it says the hypotenuse is 6 more than the shortest leg and 2 more than the longest leg. So this is the hypotenuse, and it has to be 2 more than what the longest leg is. That means the longest leg would have to be 2x plus 4. If I say the hypotenuse is 2 more than the longest leg, I'm telling you the longest leg is 2 less than the hypotenuse. So we have the following. We have a hypotenuse that's 2x plus 6. Let me draw a triangle here. Your triangle does not have to be perfect in terms of scaling because we don't know what x is. Okay? However, we do know, looking at this list of things that I've drawn, that the hypotenuse and the long leg are pretty close together. So this is the hypotenuse, 2x plus 6. The long leg is 2x plus 4. And the short leg is x. Pretty kind of straightforward problem here. How do we build an equation? I mean, I've defined all these things. Now, in order for me to find x, I need an equation. I need an equal sign with a whole bunch of x's and other stuff in it. Christy? Right, the Pythagorean theorem. A hypotenuse squared is equal to the sum of the square of the other two sides. And if you're more of an abstract thinker, I don't think you really need this diagram to proceed. Because if the hypotenuse is 2x plus 6, then when I square that, I have to get 2x plus 4 quantity squared, and I have to get x quantity squared. Now, so this is my equation, everybody, that I need to solve. I think most of us have advanced to the point where you can look at that and tell me that you know it's going to be quadratic. However, your first step in solving most equations would be to simplify things. So you need to expand 2x plus 6 quantity squared. And I don't think you need to write this next step, but I'm going to. I'm only rewriting it to remind you that when you take 2x plus 6 quantity squared, you don't just square the 2x and the 6. You have to take 2x plus 6 multiplied by 2x plus 6, which is going to give us 4x squared. We're just applying the FOIL rule here. We're distributing the 2x plus 6 in the first binomial through multiplication to the 2x plus 6 of the second binomial. Outer is plus 12x, inner is plus 12x, last is plus 36. On the other side, we do the same thing with the 2x plus 4. And then we have the x squared. You know, truth be told, everybody, this step here I don't think you have to write that either. Because I think many of you, when you take 2x plus 6 quantity squared, you know you're going to get 4x squared plus 24x plus 36. Without actually doing the 12x plus 12x. Like you kind of bypass that in your brain. But what's written in brown, you definitely need to write 4x squared plus 16x plus 16 plus x squared. And now we can definitely see it's quadratic. By the way, is an equation quadratic as soon as we see there's an x squared? Does it make it quadratic? Not necessarily, because I hope you understand this isn't the situation. But if this were the equation, that's not quadratic. That's linear, because your quadratic terms will disappear. However, we do have plus x squared. So I'm going to collect all of my terms on one side. On the right-hand side, I have x squared plus the 4x squared, but minus the other 4x squared just gives me x squared. I need to take 16x minus 24x. I think that's negative 8x. Good. And then I have minus 20 because I have the 16 and I have to subtract 36. This is not a difficult problem. And I think in years past, I've often just said when we get into review, don't forget you're expected to be able to solve word problems. I just chose to include an extra day here for us to practice them. This is equal to 0, by the way. Let's do the b squared minus 4ac thing. Good afternoon. It's all right. We do the b squared minus 4ac thing here to find out if it's factorable, because at least for me and probably for many of you, if it's factorable, it's less work. There's less of a chance of messing up if it's factorable. And then if it's not factorable, we need to know b squared minus 4ac anyway, so why don't we just find it regardless? So b squared minus 4ac is going to be a negative 8 quantity squared minus 4 times 1 times negative 20. 80 and 64 is 144. Jackpot. I think it's 144, isn't it? So 144 is a perfect square, which means it's factorable. How many of you understand we didn't really need to do that to see if it's factorable? Because this is such a simple quadratic expression, you can factor it just almost in your head right out of the gate. So we get 0. The coefficient of the quadratic term is 1. What that means is we're searching for two numbers that multiply to give negative 20 and add to give negative 8. By my calculating, I get negative 10 and 2. This means that this quadratic equation has two solutions, x equals 10 and x equals negative 2. And, you know, it's interesting because I just marked a calculus assignment that I'm going to return to my calculus students later on this afternoon. And they have a calculus problem, and the problem ends up being, it's quite a complicated problem. It's more complicated than this. It ends up being a quadratic equation they solve, and they get two answers. And one of those answers is valid and one's not. By the way, the answers they get are both positive. So there's a reason why in their problem one is not valid. I'm just pointing out right now, it's not always the negative one that's wrong. But if you're going to say here, it's not this, you need to explain why it's not that if it's a written question. And the answer is because x is a length of a side of a triangle. I'm not going to write that down. I'm not going to write that down, but you would need to write that down if it were a written response assignment or question on an exam. So x is equal to 10. What are we asked to find? I just blew right past that. What's the area and perimeter of the triangle? Well, to find the area or the perimeter, you have to know these dimensions. Well, we've determined that x is 10. What's 2x plus 4? Well, that would be 2 times 10 plus 4 would be 24. What's 2x plus 6? That would be 2 times 10 plus 6 is 26. Before we go on, can you confirm? We're not asked to do this. You don't need to show your work. But can you confirm that 26 squared equals 24 squared plus 10 squared? It better, because it's a Pythagorean triangle. It's a right triangle. So confirm it on your calculator. Take 26 squared. Or find the hypotenuse using 10 and 24. Is 26 squared the same thing as 10 squared plus 24 squared? Okay, so that's just a check to see that it's right. What's the perimeter? Well, the perimeter is simply the sum of these three sides. That's easy, okay? So the perimeter equals 26 plus 24 plus 10. The perimeter is, I'm getting, double check my math as always, my numerical math, it's, I believe, 60. And we don't really have units here, so it's just 60 units. It doesn't say anything's in centimeters. The area, well, area of a triangle is 1/2 the base times the height. In a Pythagorean triangle, you can treat the bottom of this as the base, and this is the height. I'm going to actually write the word height here, because I don't want to just put h and have you think that maybe it's the hypotenuse. That's the height, right? The base and the height have to be perpendicular to each other. So 1/2 the base times the height will give us 1/2 times 10 times 24. I believe that gives us 120 square units. But just double check. I'm pretty sure that's right. Yeah, that's good. You know, that's a Pythagorean triangle example of a word problem. I could probably come up with a dozen other different looking problems. Any questions with example 1? Okay, example 2 is a fairly common example. It's something you would expect to see on an exam. The pool has dimensions of 20 meters by 30 meters, so it's a rectangular pool. And we want to pour a concrete barrier around the pool, maybe to separate the pool water from the grass, or maybe to just have a certain area there where people can put their chaise lounges and relax in the sun and drink their cocktails. Okay? But it has to be an equal width. So if this is the pool, and I don't know, I'm going to try to draw this relatively to scale. It's 20 by 30. I mean, we could get out the rulers if you want. This is 6 wide, which would mean 10, 20, 30. If it's 20 in the other dimension, then it's going to be 4 centimeters as a length or a width. I don't know how close I'm going to be. Not bad. Good enough. Okay? It doesn't have to be perfect because we're not going to get the answer by looking at the diagram. We're going to get the answer by building an equation. But the point is, and just hold off on drawing anything else just yet. The point is that if this is the border that's around there, that's not right. Because an equal width means that whatever this width is, this width has to be. And this width has to be. And I can tell by looking at the two widths on the top of my diagram and the bottom, they're a little bit smaller. I'm not going to worry about measuring things precisely here. I'm just going to say, I'm going to keep this width, and I'm going to increase this a little bit, and say that I think that looks good enough for what we're doing. We're not splitting the atom here. We're not landing people on a foreign planet. We're just drawing a diagram. Okay, so what do we know? We know that this length is 20, and this length is 30, and we also know that the distance between the edge of the pool, right, this is the pool of water. We know that the distance between the edge of the pool and the edge of the walkway, or whatever we want to call it, border, is the same all the way around. What's the width of the path? Well, that's this, x. And this is x. And this is x. And this is x. It's x the same on all sides. Now, if that were all there were to the question, it said, what is the width of the border? You could make the border any width you want. But there's a condition there. The area of the path is going to be twice the area of the pool. So I don't think I've drawn this to scale that way. Right? I think if you were to start looking at all of the area of the border, I don't think it's, bless you, I don't think it's going to be twice the area of the pool. But that part doesn't matter. So how do we build an equation out of this? Well, there are a couple of ways to do it, but I would recommend this. First of all, let's find the area of the border. What is the area of the border? You have enough information to find it because the area of the pool is 600 square meters, length times width. And that means that the area of the border would have to be 2 times 600. The area of the border is 1,200 square meters. And now, I want to show you two ways to do this. And I think one way, to me, is simpler. But some people choose another path. No pun intended. And I want to probably show you both methods. What I am going to do is come up with an equation for the total area. That's the border and the pool. Well, the total area will be 1,200 plus 600, won't it? The pool is 600, the border is 1,200, total area is 1,200 plus 600. I want you to note that when we talk about the total area of the pool, I'm saying it's the area of this rectangle, isn't it? That rectangle, if the center rectangle and the border around it adds up to give, what is it, 1,800 for area, then the area of that blue rectangle has to be 1,800. So how do you find the area of a rectangle? It's length times width. What is the length of this? And what is the width of this? Well, the length is 30 plus 2x. It's 30, and then you have to add x on the left of the pool and x on the right. This is 20 plus 2x. And now what we have is that 1,800 is 30 plus 2x multiplied by 20 plus 2x. And I'm going to pause there just for a second. There is nothing after this that's new. This is going to be a quadratic equation, and you know how to solve quadratic equations, okay? And then we'll solve it. But I want to pause and see, does anybody have any questions in building that equation? Okay, so we're going to expand it out. I need to take 1,200 plus 600, which gives me 1,800. Equals, I'm going to FOIL this out. 30 times 20 is 600. 30 times 2x is 60x. 2x times 20 is 40x. 2x times 2x is 4x squared. Yep, it's quadratic. Can you confirm my first, outer, inner, last? Just make sure I didn't make a mistake, and make sure you're on your toes as well. Okay? Since it is quadratic, we have to zero the equation, so I'm going to leave the 4x squared on the right-hand side. I have 100x, and I have minus 1,200. 600 minus 1,800 is minus 1,200. Can I factor this? Yeah, 4 factors out of it. Did I factor the greatest common factor out correctly? Okay. Regardless of whether what's inside is factorable, it doesn't matter. We still want to take that 4 out because then we're dealing with smaller numbers. Smaller numbers if we want to complete the square. Smaller numbers if you want to use the quadratic formula. Smaller numbers if it's factorable. Is this factorable? Well, let's do our b squared minus 4ac test. You're going to take 25 squared minus 4 times 1 times 300. I want to say 1,825. Hey, okay, that's right. I don't believe 1,825 is a perfect square. So that means we have to solve this using the quadratic formula. But again, as soon as we say negative b plus or minus the square root of b squared minus 4ac, we've already done the heavy lifting there. We already know b squared minus 4ac is 1,825. All over 2a, which is 2. In a word problem like this, ultimately, I want to see your work algebraically, but your final answer is going to be a decimal. If you are the manager or the owner of the concrete company, and the person phones up and they say to you, we want a border of width negative 25 plus root 1825 over 2, you might just hang up the phone, right? You might think somebody's playing a prank on you. You want a decimal value. And the reason I'm going into detail about that is root 1825 can be simplified because 25 divides into it. But who cares? We don't need to spend time with that. We just find the answers. We get x equals negative 25 plus root 1825 all over 2. And x equals negative 25 minus root 1825 all over 2. Oh, and can you please figure out for us what negative 25 plus the square root of 1825 all divided by 2 is?
I got 8.8.
I think that seems reasonable. 8.8 something? 8.86? I'm not saying that seems reasonable for a width. I was just looking at this and looking at the numbers, and I have a rough idea of what root 1825 is, and I figured it would be around 7 or 8. On the other hand, x here let's say negative 30 something, I don't know. And, you know, how many of you can look up here at this expression and know that it's going to be a negative number without even calculating things? I mean, you have negative 25 and you're subtracting another number. It's going to be negative. This one gets tossed in the bin because you can't have a negative width. X is the width of the border. So the answer to the question to the nearest hundredth would be about 8.86, or to the nearest tenth would be about 8.9 meters. And we're done. Okay. These questions can be different. You will see examples of problems I'm going to suggest to you that look the same, but they're different. Sometimes you're given the outside dimension, and you're asked to find the width of the border so that the inside part is maybe half of the total area. It doesn't have to be this situation. On your handout, these are not all assignment problems, but what do I got? 5, 6, 7, 8, 9, 10. There are 12 different word problems there. These are the kinds of word problems you could expect to see on your exam. One final thing. You can also expect to see on your exam word problems where the equation's already given to you. Alice kicks a ball in the air. This is the equation for the height of the ball. When is the height 12 meters? You should be able to set that up and solve the quadratic equation. These problems are all you doing the hard work and coming up with the equations.